Happy Floral Shirt Friday, everybody. Welcome to another video. This is the first part in my coverage of the sensors that you need to study for the Sensors 1 research project, and it covers basically all of the sensors module. We're going to start simple with a very, very basic sensor, touch sensor, aka just a little push button. And in doing so, we'll also be refreshing your breadboarding skills, looking at Arduino programming, some very light programming, and kind of how that all comes together. Okay, so let's hop in. I've got a Tinkercad circuits file open. I've brought in an Arduino and a breadboard. So if you don't have your kit at home, hop onto Tinkercad. It's great. We can simulate Arduino code in here. We can, it's got a huge library of components to play around with. So I'll be using this for these tutorials, but anything that we do in here, you can and probably should do in real life if you actually have the hardware in front of you. So what are we talking about today? We're talking about the humble push button. This is basically the most simple form of touch sensor that we can use. Just a little button that when it comes in contact with something, click, and we somehow use that to tell a robot or whatever that we've bumped into something. Okay, there's lots of other kinds of touch sensors, capacitive touch sensors, and the more kind of advanced touch sensors like on your touch screen on your phone or a tablet. But we don't need to get too deep in the weeds in all that. In terms of the kinds of robots that we make in our class and in our club, when we're talking about touch sensors, we're usually just talking about, did we bump into something? Are we holding onto something? And a little push button switch, also known as a tactile switch or a tack switch, is perfect for that because it requires very little force to actually push it. And we can get a very clear and distinct signal to know whether or not the button is being pushed. So how do we actually use this? Let's take a look here. The way these push buttons are made is these two terminals directly across from each other are always connected electrically no matter what. Same with these two that are directly across from each other. They're always connected no matter what. They're basically the same piece of metal in most cases. What happens when we push the button is that another piece of metal, so we have those two kind of strips for those two connections, and when we push the button, another piece of metal gets pushed into contact with the two, connecting both sides together. So when we push this button, this pin is now connected to not only the one it's always connected to, but also the two over here. So when we push the button, all four of the pins are connected. When we release the button, only the ones across from each other are connected. So it's very important that we remember that when we're setting up our circuit so that we know that we're connecting the right things together. Let's take a quick look at the breadboard as a refresher, and we'll remember that these long rails along the sides are all connected. Every hole in this rail here, and you can see the green highlight, tells us that these are all electrically connected underneath. It's all actually just one piece of metal underneath. Same with this rail all the way along, and same with the two rails on the bottom. So we typically use these for our 5 volts in our ground from our Arduino or whatever our power source is, because that's the most common thing that components need to connect to, is either 5 volts or ground. So it's nice to have a lot of different holes to use for that. In the middle here, these rows, these groups of 5 pins are connected this way. So every hole in this row of 5 is connected. It's the same piece of metal underneath. And every hole in here is connected, but they're not connected together. And really importantly, the rows do not connect across the gap here. So this gap, there is no metal that goes underneath this. This is a separate row and this is a separate row. So what that means is when we have components like this that perfectly fit across the gap, it's nice because it means we're putting each pin in its own row and we're not accidentally connecting two pins together. If, for example, you take your push button and you put it in like this, what we've done is basically negated any use of this push button because we've now plugged this pin and this pin into the same row. They're electrically connected together no matter what. But the whole reason we're using this button in the first place is that these two pins are usually not connected and then they get connected when we push the button. So this is kind of nullified that usefulness. So we'll just spin it back around. We'll put it across the gap. Now, in the case of a simple push button like this, it actually doesn't matter if we have it across the gap or not in this orientation, because remember, these two pins are always connected to each other anyways. So it actually doesn't matter that we've put them in the same row. The one issue with doing it this way though is we've run out of holes to use in this row. We've only got one hole here and one hole here. So it's just much easier for us if we put the push button here. So what do we actually want to do here? We want our Arduino to know, to be able to tell whether or not the button is being pushed. Now the Arduino isn't good at knowing about like physical things, like are things pushed or not, but the Arduino is really good at knowing what voltage wires are at. So is this wire at 5 volts or is this wire at 0 volts? And for the most part, we're working with digital logic, and we'll see some analog examples later. But when we're working with things that are digital, they are things that are either on or off, either high or low. So close to 5 volts or close to 0 volts. And that's kind of perfect with a push button because we have it either connected or not connected. So that's also what we would call digital. So I'm going to show you how we'll hook this push button up, and I'll explain as we go what it is we're doing. So the first thing we always want to do from our Arduino is bring our power over. So we'll grab our 5 volts and plug it into one of these rails. I'll color this red. It's always nice to color code with your jumper cables. Just keep things tidy and organized, and so you know what you're looking at. And we'll also connect ground down to this rail. I always like to have my power rails on opposite sides as well. Just helps me keep things neat, and I can also kind of visualize the circuit. You could put your ground over here as well. Things tend to get a little bit cramped up. This is not the way we want to do it, but I'm going to show you right now and then explain in a second why. So if I connect this up like this, we'll go blue here. So right now what we have is an open circuit. No current can flow because no one's pressing the switch. But what happens is if we press the switch, okay, now current's going to flow through. Okay, so we might think, well, maybe I want to connect to one of the digital pins on the Arduino, like here. Because if I'm not pushing the button, this wire is at 0 volts. And so this will be a 0. And then when I do press the button, now we've let the 5 volts through, and so maybe this wire will be at 5 volts. The reason we don't want to do this, though, is let's think a little bit critically about what we've done here. When we push this button, we now have 5 volts connected through here, through this button, through here, directly to ground. And you'll remember that that's something we never want to do, because that's what's called a short circuit. We've made a direct path from voltage to ground with no resistance in the middle, other than the small amount of resistance in the wire. And that's not enough to limit the current as much as we need it to be in order for us to not damage our Arduino. Now, most Arduinos have built-in circuit protection. So if you do short between 5 volts and ground, the Arduino will just turn itself off rather than let one of these pins become damaged or let your wires start to burn up and melt, or let your breadboard start melting. But it's still something we don't want to do, so we've got to be careful about that. So the way we get around this is by introducing a resistor. So I'm going to take a resistor here, plunk it down here in place of that wire, and we can use any value here. Typical value we use is a 10,000 ohm resistor. So now that we have the resistor here, we can hook this up again to our Arduino. And let's think about what's going on right now. When I'm not pushing the button, there's no current flowing through this circuit because it doesn't have any way of getting from here to here. And so if there's no current, that means there's no voltage drops, which means all of this is at 0 volts, and here's at 0 volts, and as well on the other side of the resistor is being pulled down to 0 volts. Okay. This is what we call a pull-down resistor. Basically anchors the voltage down to 0 unless we allow some current to go through. Then what happens is we press this button and current can now flow through this wire, through here, and it's still at 5 volts because it's coming right from the 5 volt pin through the push button, still at 5 volts. And then right here, it hits the resistor and it loses all its 5 volts as it goes through the resistor. And then it comes out the other end at 0 volts because that's what this wire is tied to. So we've made sure we don't have a short circuit by having this resistor in place. And we have a very clear location here in the circuit where our voltage is always either 0 volts or 5 volts, which is the really important thing we want to have happen because that's really easy for the Arduino to detect. Another thing you might be tempted to do is just like have this with no ground over here and just say, okay, well, when I push the button, that's going to connect this wire to 5 volts. And when I'm not pushing the button, it's not connected to 5 volts, so it must be 0. And that assumption at the end there is what makes this not work. This pin just being connected to nothing in particular doesn't guarantee that it's going to be at 0 volts. This is what we call a floating pin, and when the Arduino's reading the value of that, it's going to detect just kind of a fluctuating 0 or 1, and that might change by magnetic fields induced by you, a human, or by other wires around it, and we just don't want to have that happen. So we'll always keep this resistor in place that's tying this back to ground. Again, that's called our pull-down resistor. This circuit is set up. Now we just need our Arduino to actually read the value of this wire. Is it 0 or is it 1? And then we want to know what it found. So in this case, we'll just have it send a message back to the computer to tell us what state the button is in. Down the road in a robotics application, you would have that value being used to control something or other. But for the purpose of this project, we're just wanting to know what is that value. As well, sending these messages to the computer about what value sensors are at and what value other variables might be sitting at is a very useful skill to know how to do because it helps you debug and troubleshoot your programs. So let's jump to the Arduino editor. And oh, there we go. I'm on the other side of the screen, so I'm out of the way. And do a quick refresher on how we use this to write code for the Arduino. And this is a very basic problem that we're solving here. So this lets us cover a lot of the basic concepts in Arduino programming. So if you have the Arduino IDE installed on your computer, it's very easy. Just go to arduino.cc and you'll find the download and installer. It's free, very straightforward piece of software. We have some buttons at the top, verify and upload. These are what we use to actually send the code to the Arduino, and then save and open and new file buttons that you're used to seeing under like a file menu like this. So we also see in a brand new file that opens up in Arduino, two functions that are already set up, but they're empty. So this one is called setup and this one is called loop. And you might remember from last year what these two do. In setup goes any code that we need to happen just once and only once at the start of the program. So when the Arduino is first powered on, it's going to run any code that's in setup once, and then any code that we put in loop, it's going to run once, and when it gets to the end, it's going to go back to the start and do it again, and then get back to the start and do it again, and around it loops until the Arduino is unplugged. By a combination of these two things, we can do basically anything we ever want to do with an Arduino. We just have to think a little bit critically about what things need to happen only once and what things need to happen every time through the loop, which I'll just refer to as every frame. So you can think of a frame in a game or a movie being when everything kind of gets updated and then put on the screen. Same kind of concept here. A frame in the Arduino is one run through of this loop. What is the frame rate, by the way, of an Arduino? Well, it depends on how much stuff you're putting in loop, how many instructions, but generally we might think about something like 20 milliseconds. So very, very quickly is it going through this loop, and we'll see that in a sec. So let's think about what we need to do here. I'm going to write this out in comments in the code. You can write comments by 2 slashes, and then anything following these slashes basically doesn't count. So this is where we can put some human readable English language text that helps us kind of think through our code, maybe put some notes in for us to see later so we understand what it is we did in the past. I like to use comments as well to just kind of skeleton out, build out what the code should do, and then I'll go in and fill those instructions in the actual language afterwards. So what do we actually want to do here? Well, the first thing we need to do is tell the Arduino a little bit about what we're doing. We need to tell it set up pin 2 for input. we need to let the Arduino know, hey, we're going to be using pin 2. Remember from our circuit that we've connected our signal from this button into digital pin 2. So we need to let it know that we're using pin 2 as an input. Another thing we need to do is start the serial communication. So the serial communication is the way we can have the Arduino send messages back to the computer. And it's very handy, like I said, for debugging and finding out what's going on. So we need to make sure we actually set up that communication, basically like a handshake between the Arduino and the computer to say, hey, here I am. We're going to be talking in this way. Just get ready for me to send you some messages. That's what we need to do in setup. Those are things that need to only happen once. Then what we need to do in loop is we want to read the value of pin 2. The value being its voltage. Is it high or low? Is it on or off? 5 volts or ground? We then want to send that value to the computer over serial. So we're going to use that serial communication to send that value back to the computer so that we can see what's going on in our serial monitor. Okay, so let's go in and fill in these blanks with actual code, and we'll talk about some key things with the Arduino language along the way. So number 1, set up pin 2 for input. Okay, in order to do that, we use a special function built into the Arduino library called pin mode, P-I-N, and then capital M-O-D-E. And you'll notice as soon as I finish typing pin mode, it turns orange. That tells us that this is a function that is built into the Arduino library. So we haven't made a typo, and it's something that actually exists. So the way that functions work in the Arduino language and many languages like that is they have a name, and then they have some brackets. And inside this brackets, we put in any arguments or parameters that function needs in order to do its thing. So the pin mode function needs to know what pin are we using and what are we using it for, input or output. So pin mode in brackets 2, and we separate the arguments by a comma. And the second argument it wants to know is input or output. And so we will say input. And you'll notice again, I've typed this in all caps, and as soon as I finished typing it, it turned blue, which indicates to us that this is a special word that means something very specific to the Arduino language. Now, what if you don't remember what functions are called, what arguments or parameters they need, and what things you can put in for those arguments or parameters? The easiest way to look that up is if we hop back into our browser and we go to, let's just search for Arduino reference. And the very first hit is from arduino.cc. It's arduino.cc/reference. And this is a list of all of the functions built into the Arduino language. And right here at the top, here we see pin mode. And in here we can see some description about how to use it. So it's wanting a pin and a mode. And it tells us that the pin just needs to be the number of the pin, and the mode can be one of these 3 options: all caps, input, output, or input pull-up. Input pull-up is a special thing that we won't really get into. You can dig into that if you want, but it basically is a way of hooking things up so you don't need a pull-down resistor. So we'll flip back into here, and we'll see that we've set that up already. And one other thing you'll notice is this semicolon that I've put at the end. This is very important. Any instruction in the Arduino language needs a semicolon at the end to tell it, hey, this is the end of a line. This is the end of an instruction. Functions, function definitions like this, don't need a semicolon at the end. But when we're actually using a function or any other instruction, that needs a semicolon. So there we've done this step, set up pin 2 for input. Let's move on to the next step, start the serial comms. The way we do that is another built-in thing into Arduino, a little bit of Arduino arcana that you just kind of remember, and that is we go serial.begin, and then this kind of arcane number 9600, and then a semicolon. Okay, again, if you don't remember any of this, flip back to the reference page. We'll go back here and we'll look around for serial stuff. Let's see. Oh, here it is, communication serial. Let's click into there and we'll see all the different things that we can do with serial. There's some examples we could look at, but here's serial begin. And we'll see here that what I typed in, that 9600, is actually the speed. The speed, also called the baud rate. This is basically just a parameter so that the computer and the Arduino know kind of what frequency these characters are being sent. We'll see why it's exactly 9600 in a moment. So let's flip back to the Arduino. Let's hop into the loop part of our program. And we need to first read the value of pin 2. And I should add here, and store it in a variable. So kind of two steps actually that we need. First, we need a variable, and then we need to read the value of pin 2 and store it in that variable. If you don't remember what a variable is, just picture it's like a box, and it's a box with a name on it. It's got a label, and inside that box we can hold information, and we can always get to that information as long as we remember what the label on the box is. So let's start by making a variable to hold the state of whatever this value is that we're reading on pin 2. So here's how we set up a variable. I'll make this an int, and I'll talk about that in a second. We'll give it a name. I'll call it button state, and a semicolon. So what this line of code means is basically, hey, Mr. Arduino or Mrs. Arduino, who knows, I would like to create a new box for holding information. The label on that box is going to be button state. And what I'm going to store in that box is an integer. So we need to tell the Arduino what kind of data we're storing in our variables so that it knows how big to make the box. So in this case, the variable that we're going to get is an integer. Now it's actually only going to be 0 or 1, but those are integer values. So we're going to make this variable capable of storing integers. So we say int button state and then semicolon to say that's the end of that instruction. And now I'm going to give you another instruction. The next instruction we want to do is we want to set the value of button state equal to this little line, digital read 2. Let me explain this whole line of code. So button state equals, what this is doing is we're basically saying, here's the information that's going to go in that variable. Here's the information I'm storing in that box. So we're setting the value of button state to whatever the result of this is. Digital read 2. You'll notice it is orange, which means it is built into the Arduino language. Let's take a quick look in the reference. Let's look around here. It is digital read. Okay, reads the value from a pin, either high or low. The parameters it needs is the pin that you want to read, and it returns either a high or a low, a 1 or a 0. These things are the same. So let's hop back into our code, and we'll just review this line once again. So we're saying the value in this variable button state is going to be equal to whatever the Arduino senses the voltage is on pin 2. Is it high or is it low? Now the last thing we want to do is send that value to the computer over serial. And so we're going to say serial.println. And what do we want to print? We want to print whatever the value is stored in this variable. So what println does is it sends a message to the computer over serial, and it adds a new line to the end of that. So it's like it hits enter every time. Makes it a little easier to read. And then what println wants in brackets is whatever the message is that you want to send. This message could just be English. We could say hello, or that has to be in quotes, or it could be a variable like button state. And in the case of this, it'll send what value is being stored inside of button state. So this code is all ready to go. Let's do a quick review. First, we're setting the Arduino up to know that we're using pin 2 as an input pin. We are then telling it that we are going to be using serial to communicate. So please set that up. Then every time through the loop, we're going to create a variable called button state. We're going to store the value of the voltage on pin 2 in that variable, and we're going to send that value on the serial communication to the computer. And those steps are going to happen over and over and over and over again until we unplug the Arduino. So if you're working on an Arduino at home, a real physical one, you'll want to plug it into your computer right now and get ready to upload to your Arduino. The first thing you need to do every time you plug in an Arduino and you want to upload code, you have to go to Tools and you have to go to Port. And under yours, you will see a COM3 or a COM7 or something that is the COM port that your Arduino is plugged into. It might even say Arduino Uno in brackets next to it. That's really handy. If you don't know which one it is, just unplug it, close this menu, open it again, go to Port, see what one is still there. It's probably your mouse or your keyboard or whatever. And then close this again, plug it in, open it up. Whichever number has just appeared, that's your Arduino. So you have to make sure you select that here. And then you can go ahead and hit upload. When you hit upload, what it's first going to do is it's going to verify the code. You can do this separately by just clicking the verify button. And it might ask you to save the code. And then what it's going to do is it just compiles the code, which means it reads it through line by line, turns it into machine code, a series of ones and zeros, and lets you know if everything was successful. We'll see down at the bottom here some message about, okay, yep, it's done compiling, here's how much space it uses, and good to go. But it doesn't actually send anything to the Arduino unless you hit this upload button. Now, I can't do that here because I don't have an Arduino plugged in, but I'll show you how we can use the Tinkercad simulator to do this as well. So I'm just highlighting this all. I'm hitting Control-C to copy it, and I'm going to flip back over to my browser into Tinkercad, and we'll see at the top here there's a button called Code. Pull that up, and that opens by default this like blocks, like Scratch style interface, but we can switch that over to text. Yeah, give me the text, please. We'll erase everything that's already in here and paste in the code that we just wrote in our Arduino IDE. And now that's ready to go. And we can imagine that now it's been uploaded to the Arduino. So if I go ahead and hit run simulation, nothing happens. We can press the button and still nothing happens. But what are we expecting to happen? Well, what we're expecting to happen is that the Arduino is sending some messages to the computer over serial. So maybe we're just not seeing those messages. In Tinkercad, we have a serial monitor button down here in the bottom. I'll open that up and ooh, there we go. Look, we're getting a string of zeros being printed. And if I press this button, now we're getting ones being printed. So if I click it, we just get a few ones followed by some zeros. So it looks like it's working. Now, where would you find the serial monitor in your Arduino IDE if you're using a physical Arduino? If you go up to Tools and you go Serial Monitor or Control-Shift-M, or even easier, this little button here in the corner. So, okay, that's cool. We've got now our Arduino telling us if the button is off and if the button is on. So that's pretty handy. Let's talk a little bit about how we can tighten up this code a little bit just to make it a little bit more concise. And then talk a little bit about programming and some things that you can do with this information. So back in our editor here, one thing that I'm noticing is I can actually condense this a lot. So right here where we're creating our variable button state, and then we're setting the value of it in a separate line, we can actually combine these two lines together. So I'm just going to get rid of this. And so now we've done that all in one line. We've created the variable and we've set it equal to the value of digital read. And then here we are printing that to the serial monitor. Now, one thing that you can do, and I'll show you here, but then I'll explain why you might not want to do that, is you could actually get rid of this whole variable business and just say serial.println the value of digital read to. And this will work exactly the same. We'll get the exact same result on the serial monitor, but this is not a great way to set things up because now there's nothing we can do with the value of the digital read. We don't have it stored anywhere, so we can't make any decisions based on it. So it's not terribly useful to do it this way. So while I could condense this down to a single line, I'm not going to because I want to have this value stored in a variable so I can use it. So what things could we do with that? Well, what if we wanted to print a message, a different message based on the state of the button? What we can do now is learn a little bit about if statements. I'm going to write this out in a comment. What I want to do here is print a message only when the button is pressed. Okay, that's my human language for what we want to do. So how do we actually write this in code? So we use a special term called if, and you see it turned from black to gray, meaning this is a special word. And what if wants is, in brackets, some comparison or logical expression that's going to resolve to either true or false. So we can say if button state now equals 1. Only then, let's go serial.print ln, and we'll put in quotes, the button is pressed. Hooray. Now I have to put this in quotes because this is not code. This is just human language. So when we put it in quotes, that tells the Arduino, hey, these are just some characters that I want you to print. They don't have any special meaning. And if we do this, let's copy this. I'll put it back into our here, and we'll start the simulation. And it looks like I'm missing a semicolon. And there we go. So right now, we'll open up the serial monitor. I'll clear it from the last time. And we'll see nothing's coming along from the Arduino. But if I press the button, now we get this message for as long as I'm pressing the button. And you see in the simulator how quickly those frames, those loops are happening. And it's actually much slower in the simulator than in real life. So this is happening very quickly, and we're getting these messages printed out to the screen. So what this is doing is this if is basically taking this expression, and if this expression is true, it does the thing inside the brackets, and if it's not true, it does nothing. And we just skip that part. An important thing here is this equals equals. Up here we use the equals sign just once. And when we use just a single equals sign, that means we're assigning a value to a variable. If we want to compare if one thing is equal to another thing, we have to use the equals equals operator. So there are two different things. One other thing that we can do here though, first of all, I'll just show you, we can actually make this, we can say equals equals high in all caps. This is a special word in Arduino that actually just means the number 1. Another thing we can use is the word true in lower caps. Again, just a special word in Arduino that means the number 1, but sometimes it's a little more expressive to use language like that. And one last little trick we can do is actually, because we know that button state is either going to be 0 or 1, we can actually just get rid of this entire evaluation and just say if button state. Because remember, this if bracket is only looking for something that's going to resolve to a 0 or a 1, or true or a false. And since button state is either going to be a 0 or a 1, or true or false, then we can do this. And just saves us some typing and makes things a little bit, maybe a little bit more clear in terms of like the human language. So here we're saying if the button state is 1, then print this message. And I'll leave this equals equals 1. What if we wanted to print a different message if it's not 1? So we could do this. We could just basically copy and paste and say if button state equals 1, print this. If button state equals 0, print this. And this would work, and this is fine, but there's an easier way. Okay. There's only 2 cases here. Either we've pressed the button or we haven't. So what we get to use is a special word called else, which has to follow an if. Else makes no sense on its own. And basically it means if this wasn't true, whatever else the case is, do this. And so if we copy this in, paste it into here, okay, and start the simulation, open up the serial monitor, and we see button is not pressed, button is not pressed, button is not pressed, until we press the button, and now the button's pressed. So that's pretty handy. So we can send a different message based on the state of the button, and they can be 2 separate things entirely, which is very handy to be able to do. And you can imagine that instead of writing something out to the serial monitor, you could be having the code do anything else, turning on or off motors or whatever. Okay, this is why if statements are a very powerful thing to have. That covers very quickly, I know, the broad general concepts of breadboarding as a refresher, setting things up, hooking things up on the Arduino, opening up the Arduino IDE and writing some quick code and doing some very basic tasks using the digital read to find out what voltage a pin is at and using the serial monitor to send that message to the computer so that we can see what's going on. But that is essentially all that you need to know how to do in order to accomplish the Sensors One research project, because all I'm asking you to do with the code is hook up the sensor, write some code that finds out what value the sensor is returning, and prints that to the serial monitor for us to verify that it's working. Now, as we look at some more advanced sensors, the code is going to get a little bit more complex, but at the end of the day, this is all we're doing. And I'll leave it to you to imagine, or if you want to explore on your own, ways of actually applying this into a project. But that's beyond the scope of the research project, so don't worry about that for right now. The next thing we're going to look at is how we can sense rotation using a potentiometer. Much later, we'll see how we can sense rotation more accurately using an encoder, but that's going to be down the road. Some other sensors we're going to look at are the ultrasonic rangefinder to sense distance. We'll also look at using a thermistor to sense temperature, and probably a few others sprinkled in there. So those will be in future videos. I will catch you next time. Have a great weekend, and happy Floral Shirt Friday to all of you.